In the last session, we have seen how to use subqueries in terms of inner query and correlated query. In this session, we will take a look at joins. So why do we need joins? Since the data is spread across multiple tables, in our case we have only 2 tables, but there will be n number of tables if we are working on a big project. Then to get a meaningful data out from all these tables, so we should perform a join, and the result of join will be a meaningful and useful data which the user can work with. So in order to get that, we need to combine or join these tables together. So there are several joins available. So the one which we are going to look at today are inner join, outer join, and within outer join we have left outer join and right outer join, and there is a full outer join, and there is a cross join or Cartesian join. So we will look at this with an example now. Joins. Okay, so right now we have 2 tables. Before I jump into queries on joins, what I have done is I have added a few more entries into the department table. So now if you look at the employee table, we have 12 entries, which is same as in the last session. However, I have added 2 more entries into the department table, and we don't have any employee for these 2 items in department. One is QA and DevOps. Okay, so let us go back here. Now let us look at inner join. Okay, select star from employee inner join. This is the syntax, inner join. Which table are we going to join with? Department. And we need to specify the condition on which column we are going to join it on. So we know that the employee has got a column name called department ID, which is linked to the department ID. Okay, so what we are selecting is we are selecting everything from employee, and we are joining them with the department on this particular column, where department ID is same as the department ID column. Okay, so let us see. Now after joining these, as you can see, since we have select star, so it has joined on this particular column, and it has printed employee as well as department details. If you look at department ID and ID here, they are exactly matching. So that is where we have combined these 2 tables into. So department ID is same as the ID from, so this particular ID and name is from department table, and all these are from employee table. So they are combined together. Now instead of select star, I just want to see only the employee table details, not the department table details. Okay, so here I can add an alias here, E. So E now represents employee, and the same way department as D, on, instead of now providing employee, I can specify E dot department ID and D dot ID. Okay, so now E represents employee, so I can also give EMP or DEP here. So if I change that, then EMP and DEP. So you can give any name here. Okay, so which will yield the same result. For now, for simplicity, I will add only E and D. Okay. Okay, so now if I want to display only the employee table details, so all I can do is E dot star. Okay, so now I don't get the department table details. Even though they are joined, I will get only the employee details. So now if I want to display both, then I can have D dot star or star as before. Okay, so now it displays both. So now if I want to pick up some specific columns, then I can do it by using E dot name, E dot address, E dot grade, and then E dot salary. Okay, and grade, and here I want to display, instead of department ID, I want to display department name. So department is referred by D dot name. Okay, now you can see that. Okay, so Jack is okay. Jack from this particular New York address is of grade 1 and he's working with big data. Okay, and then his salary is 5,000. Now you can also give alias name here. Okay, so here as full name. So this will be the column name, and instead of name here, I can specify as department name. Okay, since I have specified the space in between, you can have it as double quotes. Okay, so now I will execute the same again. Okay, now you can see full name, this is the address, grade, department name, and salary. So this is how we can get a meaningful information by combining it together. So this is inner join. What inner join will do is, so it will only join it will only join those which matches this particular criteria. For example, where there is a department ID is equal to ID. But if you look at the data, whatever we have, okay, so we have 12 employees and there are about 7 departments. So 6 and 7 are not mapped anywhere here. Okay, so that is the reason we don't see QA and DevOps. So if you look at this, so there is no QA and DevOps. Okay. So what inner join will do is the common. So the common items based on join criteria. Okay. So this is our join criteria. Okay, so this is our join criteria, and based on this criteria, whenever both the tables have this common join criteria, then only it displays. So that is why we don't see the other two. Okay, so now let us look at outer join. Okay, first we will look at left outer join. Okay, I will copy this and then I will paste it. So instead of inner join, I will put it as left outer join. Okay, so let's execute. Okay, so in this case, what will happen is it will pick everything from plus common items from left table. So in our case, left table is employee table and the right table is department table. So what it picks up everything from left table and joins it picks up everything from the left table, so whatever the items we have, plus the common items between the two tables. Okay, so right now there is no difference between inner join and outer join as of now, but if you look at the next query, when I say instead of left, I will say right outer join. Now you will see some difference. Okay, so what is the difference? The difference here is now you can see 14 records. Earlier with inner join and left outer join, we were seeing only 12 records. Now we have QA and DevOps. So what right outer join will do is, so it will pick up everything from all from right table plus common from left. So in our case, right table is department table, so it picks up everything from department. So that is why you can see all the departments being displayed here, including QA and DevOps. However, if you look at QA and DevOps, it says null here. Okay, for full name, address, grade and salary, it says null. So that means we didn't find any values in the left table, which is employee. So those missing items will be displayed as null. Suppose if we had an employee which was not mapped to any department, then we would see the same items with department as null. So since we have a referential integrity check, so we cannot add the items into table 1 without referencing it to table 2. If you want to see how this left join works, then what you can do is you can take out that foreign key constraint and then add a new entry into the table which doesn't have any specific department ID. For example, after removing the foreign key, you can add in few more rows here and specify the ID for this particular department ID which doesn't exist in this department table. For example, there is no department ID for 8 and 9. So you can add 2 more rows here and with the department ID as 9, 8 and 9, and then run this query. This left outer join. And you should see null value for a department. Now we'll see full outer join. Okay, so here instead of left or right, we will have full outer join. Okay, so it's a combination of left and right. Okay, so it's a combination of left and right. So it would display everything, that is everything from left and everything from right plus common. Okay, so the last join which we are going to look at is cross join or Cartesian join. So in cross join, what happens is cross join. So earlier for all the other joins we have provided this criteria which is a joining criteria. So in cross join we won't have that criteria. Okay, so select tab from employee and cross join department. Okay, so what cross join will do is for every employee record it will link to department record. Output of this cross join will be the total number of records will be multiplication of the total records from employee and the total records from a department. So right now we have 12 records and here it is 7 records. So there should be 12 multiplied by 7, which is 84 records. So if you look at this, there will be 84 records. So every item from table A will be linked to every item in table B. So that is what happened here. So if you look at here, check, okay, check big data platform, check finance. Okay, so this doesn't make any sense in our context, but however, let us assume that all these employees have some common benefits. Okay, so irrespective of which department they join. So what I have done here is I have added another table here called benefits. So if you go to it's a simple table which has got ID and number of paid leaves, number of sick leaves, and the bonus percentage. Okay, so now this is applicable to all the employees. To creating this, I have also added one row which is number of paid leaves is 20, number of sick leaves is 5, and bonus is 10%. And since this is applicable to all the employees, now I can cross join. Instead of department, I can cross join benefits. So now this makes more sense because every employee is having the same benefits, or these are fixed benefits for every employees.